Hello. Hello. Compare it.cast count to best count. Okay. This is going to be always a little more annoying than I wish. I don't know why I'm... Maybe we don't need to make copies here because what we are doing here is not as complicated, question mark. Okay. Whittle must implement matches by cast count. Matches. But that happens here. Compare. Cannot convert argument from a local array. Well, let us make it a local array. Except maybe we don't want it. Ah, ah. Okay. So this still won't do anything new. Still does the old thing. However, we should be able to make it do... Okay, our printf. So it's saying there's two matches. That's true. But it says cast count null. That's no good. Cast count string. Cast count to string. Why is that? What? Oh, it's because maybe if there's literally no casting, we return null, which we probably shouldn't. Casts. Perfect match. Perfect match. Another perfect cut. Does it just add? Perfect match. Argument 2. It shouldn't say argument. It should say... It's not really an argument. Oh, we're in the wrong file. Index. Let's say index. Uh, type restriction array index whatever. This is a weird thing where, you know, conventionally when you're saying an argument index in a programming language, you start with 1, but array indices start with 0, and this is an array index. Okay. But this is matches. Okay, we're printing the wrong thing. We're printing the match index. We want to print match arrow index, and this is auto there, and then we won't say matches of I everywhere. Cast count. What did I do? Because that's obviously an arrow now. Don't you know anything? Don't you know anything? How's it going? Chat is so quiet today. Okay. In the case of the argument, the type of this argument met more than one possible target type. Not let's say matched. Argument matched multiple target types at the same level of casting, so the match cannot be resolved. I mean, this is kind of stupid in this case because we just put the same type twice, which it could match the type in that case, but like, I'm just going to let that be an error for now. Fuck you. Just don't put the type in twice. Here's the type restriction. Types, boom. Here's the array of types. We put both of these because this could be defined in another file for all we know. 2 cast matches. We should put no label here, because we don't need to see that site 3 times. Okay. All right. Seems like it's just you. I mean, Twitch.tv tells me there are 53 people. Which, to be fair, is substantially lower than average for this stream, but it is Sunday night at 10 p.m. on a holiday weekend after everybody's been doing Thanksgiving things. Okay, so now that we have done this, we now need to do the check that types match and so forth. That could get messy because we have to yield like every frickin' thing. How do these other languages that people are making, none of them really try to do nonlinear compilation like this, right? Because there's no way. It's like more than half of the work that I put into this compiler is like to do that. What do they all do? Do they just compile things in order? Do they have header files? Like, what's the deal? Okay. Let's run it on the tests so that we can take the W. Thanksgiving a week early. You're not allowed to do that. You're not allowed to celebrate Thanksgiving a week early. A more strict hierarchy for module ordering. What about within your own program? Do you have to divide your own program into modules? Every directory is its own module. How are directories ordered relative to each other? Can they not reference each other? How do they know when they can reference each other? Can they only reference functions and not data? A Canadian, oh no. No cycles. Oh my God, that's horrible. What? How do you people manage? No cycles, no cycles between module use? Is that what you mean? Like there's a strict hierarchy? So the module has to complete before anyone can use it? Well, here's what I will say quite honestly. It was definitely one of my priorities when designing this language that we wouldn't have any kind of restriction like that. But because I never tried that, because C++ is like way worse than that, right? Because I never tried that, I'm not sure to what degree it's a problem in practice for a good program, right? So I don't actually know how much I'm saving by doing this metric ass ton of work. It does make it difficult for large projects. I mean, the thing is, yeah, I don't know. I honestly, I haven't analyzed what the current cycles even are in our system in terms of we have the standard modules that come with the compiler. I don't even know to what extent there are cycles. So that would be an interesting thing because you could find that just in a meta program. That would be an interesting thing. Like, what does this actually let us do and so forth? But okay, so that doesn't answer everything though. Like, what if I've got some code in one file and it uses a struct defined in another file, but they're in the same module, right? I'm assuming that works. Like if you're just using a data structure in a function, that works completely okay. I see. So the question is, do they have some kind of machinery kind of like what we're doing for that, or are their structs just a lot more restricted than ours? Because a lot of the work we do is just for cases like that. Like, for example, the pain in the ass that we are about to have is because anytime we write code that calls check that types match might yield and tell us to come back later. Because a type might not be ready. Now, maybe we should fix that. There might be ways to fix that, but there might not. Because of all the features we have with structs, like, we have as, and you could as a pointer to something, that has an interface that like has a function with a modified directive, and we have to like run code to even figure out, like it can get crazy. So I don't know, maybe it's a feature set thing. There sure are some emojis in chat now, aren't there? Hello, people. Hello, emoji wielders. All right. Time for the pain. To the pain. Okay. So this loop here, first of all, because we can yield, we need to save this index persistently of what we're working on. Do we even have a place to put that? So we have a type instantiation and an array literal info. Neither of those is so good. Maybe I don't want to do this tonight, but there's definitely room in this compiler for like a hash table for this system just needs a data structure for this thing. And it can erase it when done. We have a type instantiation. We have a silent check back channel, which isn't going to persist long enough. That's it. We could pass the polymorph. So here we have a polymorph, a match status. A match status. Match solver input. That is what I would pass to here that has the integer on it. What about this? Match solver input. I don't know why I'm typing in Visual Studio. It's such a butt pain. Why did it? Oh my God, it changed all my stars. Holy fuck balls. Why did you change? Fuck you. Why did you change all my stars to the kind of stars typed by people who don't know C++ and don't understand how it works? These are idiot stars. All right. I hope I didn't change them in the whole file, dude. That'll teach me to use Visual Studio. No, okay. All right. That's the default for Visual Studio. You're just restating my question. Why do they have shitty idiot stars as the default for Visual Studio? And then why do they think they can change my perfectly good stars to shitty idiot stars? I act like I've never used a Microsoft product before. I mean, it is a rhetorical question. I know why. It's the same reason why they're preloading Windows Explorer now. Does my version have Copilot bugging me? Not actively, but I did accidentally press the Copilot button on my laptop yesterday, and a window popped up, and it was like loading something for a long time, and I just closed it before it could do anything. Okay. So now that is passed. The gas is passed. So we're still in the same zone. We could ship the compiler at any time. So is match solver input here? Yes, sir, it is. Int, let's call it S32, passes implementation test cursor. Used only for calls to passes. Implementation test in case we need to yield. I yield, sir. Okay, so down here. Okay. So, while input passes implementation test cursor is less than info statements in order dot count, index equals this. Okay, and then we're not going to defer. We can't use defer anymore because that'll fire even if we yield. So we need to say down at the bottom where we say next iteration plus plus because we're in C plus plus. All right. So now that should still work. Oh, we don't have it. Statements in order subindex element. Statements. It. There is a customer demand aspect for it as well. Yes, but here's my question. Should you make your defaults good for people who know how to program and want their programs to be correct, or for people who don't really know how to program and want to feel like the star goes somewhere that it shouldn't? Like, which one of those is the right answer? It's up to the shareholders. Yeah. If you think that decision was the subject of a vote at the shareholder meeting, I don't think it was. Of course you can change the default formatting style. Yes, you can change a million things. And then next time they update, it'll fucking change it all back. And next time I need to reinstall Windows on one of my 17 computers, it'll change it back. Like, how do you guys not? Yeah, never mind. I'm just because Microsoft engineers need to use the app. Yes, that is quite likely an answer. That is quite likely a good answer. You thought that's how, I mean, it is how computers work now. You are also correct. You're not sure anyone at Microsoft uses their software. Well, so what I happen to know is for a while this was true, and it's probably still true, which is that the team that works on the operating system did not use Visual Studio to debug at all. I doubt they use it to compile either, right? They probably used shell scripts to compile, but they used WinBag to debug, not Visual Studio. And this was after Visual Studio had been around for like 10 years. So I don't know what the rationale is for that. Microsoft employees regularly swap to Hangouts because Teams is actually that bad. I mean, I've only used Teams a couple times when somebody else sets a meeting on Teams. It so far has not seemed actively worse than Google Hangouts, but maybe I haven't used it enough. I don't know. I mean, Google Hangouts is pretty bad in a lot of ways. Not least of which is the frickin' video quality, dude. As someone who works on Windows, most people still use WinBag. Yeah. Okay. I mean, I'm not that surprised because at some point, if you hadn't adopted Visual Studio after like, 14 years, then it's never going to happen, right? Yeah, really the only really serious problem I had with Teams was like one time I was trying to get on a call and like Teams was installed locally for some reason because I guess it is now in Windows, but it also goes in the browser and like I think I clicked open locally and then I was like, "Oh, that's a bad idea." Oh no, I clicked open locally. It was opening really slow. So I clicked back and said, "Let me use the browser version," and closed the local version and it was completely fucked at that. Like I couldn't, nothing worked, and I had to go join from my laptop. So that was not good. But if I'm successfully in a call, I haven't had that bad of a time. Good luck with the job interview. How would you even debug the system itself with Visual Studio, though? What do you mean? Obviously, you could. Is that a question from someone who doesn't know how operating system development works? That's an actual question. Um, I mean, so here's the thing. Your operating system kernel is a program like anything else. However, it has different permissions than other programs. And I mean, depending which operating system you're talking about, it has a different memory view that comes with certain restrictions, right? So often, in fact, so for Linux, I don't know how it is in Windows, but in Linux, for example, um, you're using physical memory addresses the whole time in the kernel. At least you used to be. I think maybe they changed that at some point to make things easier. Um, but so like pointer behavior is kind of different. For example, um, like I think, and again, maybe they had a way around this, but like I think, for example, that means you couldn't have a data structure in the kernel that crosses a page boundary because like you wouldn't know where the other page is unless you reverse. I mean, I guess you could look at it. It's not that you couldn't have it. It's just you wouldn't be able to use normal pointer math if it crosses the boundary, right? Stuff like that. Okay. Um anyway, let's try to do some more work before it's time for me to go to bed. I think while we were talking there, I should have been running tests cuz I think we take the W now. And once we take the W, it's gravy. Like it would be nice to finish this tonight, but it's kind of late, you know. And we could do it tomorrow. I was thinking about shipping a new compiler build tonight, but now I'm like, I'm a little tired. Chances of making a mistake are higher when tired, of course. Therefore, let us not do that. Um, so then all pressure's off. It's like we're just doing a good job on this feature. All right, so somebody said I could. Oh well, we don't need that dummy statement anymore. Okay. So we want to call check that types match instead of. This is where it gets messy. We're going to call check that types match. Um, that passes a yield, and we need the silent check as well. All right, check that types inst value. I mean, we want to be able to pass a switchable expression because we want it to be able to insert a cast. So that would be in the match solver input. X per given. X per given. Okay. Instead of doing all this goofball stuff, we're going to say bool matching equals typer check that types match source type. That's like source code starring what's his name? Donnie Darko. Source type. Wait, no, we don't. Check that types match. Oh, wait, matching. That's where we want to go. It used to be in typer a long time ago. Wanted given expression. All right. Not L matching, just matching. Source type. Okay. Given expression, input. I don't remember what that was. Yield upon my yield. Why did I say boo? And site. Okay, that's not everything we want. That's not the overload because there's no silent check here. Wanted given site. Oh God, do we only have the full ass thing for silent check? All right. All right. Check that types match. Source type. CE. Right. Site. Null. Ampersand. Input whatever. We don't know what that was. Silent check. My yield and outer flags, which we don't know what that is. It's the default. So, asked my yield is null, I guess. Okay, and now if, let's put this out here so it's not missable. If my yields, right, assert yield upon not equal to null. Actually, it's just ice. If yield upon interp ice site, we need to yield in passes implementation test, but we were not passed a yield upon. Return null. Okay. Else, actually, we could do it. You know, we do positive then negative, right? If yield upon star yield upon equals my yield. Otherwise this, and then we return null holio. All right, so match solver input expr given, right? Right, I guess. Who knows? Ice interp reporter dot ice. Next iteration unreferenced label. Oh, because we're not doing anything. If not matching, go to next iteration. We probably don't need that. We probably don't need this label anymore. Question mark. Otherwise, we fill out overload info. Okay, what's down here? What is this? If it's a type definition, this is else. We don't need to say else here, by the way. By the way, by the by, we can accident all of these. Okay, wait, this seems like too much. Wait, what? Okay, hold on. Hold on. Okay, I don't like how indented we are. I'm going to make a mess here. If it's not a literal, okay, we get rid of that. Obviously, we got problems. Okay. It must be a constant array literal. Okay, that's weird. I don't think that belonged anywhere. So I don't know what's going on there. It must be an array whose element type is type. Yeah, we're just going to check these in early out on them. Okay, if the array element type is not type, return null. Boom, got him. If it's not a literal, return null. Got him. We do all this stuff. Got him. Okay, there we go. Literal. Oh, this is the wrong error message. Um, all right. Something like that. Nope, don't run the game. Okay, we're still good. Wait, now we're saying it did not match any possible target types. That should not be what it says. That should not be what it says. So we need to check this. You know, I'm just going to delete all this. Oh, no, we don't delete all that. We're still not adding the overload info. Okay, by the way, that was fucked because this is a value copy and we were setting those. So we're going to do this. We're going to go there. We're going to go there. Okay. Still did not match any, supposedly. Okay. Well, that would imply that we never get here, which is strange. Or we somehow skip all the items. Okay. So let's make it easy. So this is, we're going to comment this out. So we only have one case. We've got a U8. We're passing the U8. We're going to put U8 first. So that when we step through the code, it's literally the first one, right? Oh, now it works. Okay, well, that's a clue. That is a clue. What if we put it second? It also works. What if we put it third? Wait, did I just not recompile? Wait, that's what it was. Oh, maybe it was complaining about the U16 one. I didn't think it was. Did not pass any of the possible target types. Oh yeah, it's the U16 one. That is very strange. Because U16 is literally in there. Like, what? All right. Let's put U16 first. Why not put 3 U16s? Couldn't hurt, right? Did not match any of the possible target types. All right. Here we go. Could it be because it has U16 twice? No, the whole point of that is that we should get multiple matches and get an error message due to multiple matches. Okay? We don't want a 0 matches. That's no good. Matching. Okay, element, so index should be 0. CE number flags 641 OX 281 2 is 16-bit unsigned 16-bit. All right, that's a U16. Does it match? Matching. True. Oh, you know what? If we were to yield, we're not keeping the matches. So that's not good. That is not good. But I don't think we would yield here. Let's see. 1. Wait, should it have made... Okay, it should have casted to U64, so that's busted. But that shouldn't be a problem. We got 2 matches because it's U16. We should end up with 3. And we shouldn't yield on number types. Okay. So, oh, we got 4. Maybe it did do U64 and I missed it. And that was S64 that it didn't do, which it actually should have done. I don't know. Figure it out. Whittle must implement matches by... Okay, so this is going to return 0, right? No. Wait, what? Oh, because silent check. Oh, no. Okay, here's what's happening, guys. Remember when I said all the work that I put into this freaking compiler is for the yielding and stuff? Here's the deal. When we get an error and we don't match, it happens twice. The first time it happens is the actual time we don't match, which is like during the solver. But during the solver, errors are turned off. Errors are soft fails because the whole point of function overloading is you're trying things against a lot of things that they don't match, right? And if that's a compile error, then you can't have function overloading and stuff. So we do a first pass where we're trying stuff out. That's what this silent check variable is, right? And if silent check is turned off, then we go through here and do stuff. Now, remember when I said, oh, this matches set is going to get reset if we yield because it's a local variable. It'll also get reset if we call back later with silent check true. And so that's what's happening. That's why it says there's no matches. It's actually erroring because there are multiple matches, but it's telling us there are no matches. All right. In other words, when the woodsman is like, got a light, they're like, no. Got a light. Okay, so this is going to go bloat this freaking data structure here. So we're going to change this to a pointer, even though most lazy C++ people would put a reference. And the reason is because we have principles. We have principles. Even though it's more work, must implement matching info. Oh. It's C++. You can't just put things in your program. What? Unknown override specifier. I think that means it doesn't know what cast count is here. What if I do this? It'll say unknown size. Undefined struct, yeah. So now we have C++ fun. Because you can't just fucking... Where's cast count? ass.h. Where are we being included from? In pch.cpp. Fuck. So this has to go there. Oh God, we have a cycle. Hopefully that's the old... Nope. Nope. God damn it. Dude, I'm about to baby rage so hard. Why am I programming in C++? This is such trash. Okay, I don't know what to do, guys. This is like a legit header file deadlock of a magnitude that I have not had in quite some time. I think the answer is we have to move cast count into the global. Oh, and also I've got just a window that just hangs out on top of everything. I've got to move cast count to the global header file, I guess. Wait, it's already in ass.h. Wait, what? Okay, hold on. Let's not. We've got to go back to PCH. No, we got to go back to general. Put that back where it was. Okay, so this literally has to go here, and we hope to God it doesn't use other data structures. It doesn't. Try cleaning the project. No, this was a legit, like, everybody needs to use everybody else situation. So stupid. All right. Okay, now we've got a massive... I forget the definition of local array. What is the definition of local array? Is this going to erase itself? On heap equals false. Let's not use local array, so we're going to have to change some things. This is just a small optimization I tried to use. I don't know why someone made an on heap version of that. We're not going to use that. All right, so the problem with that is this whittle should not be a local array. And then $51. 1. Have I tried C++ modules? No. After C++11, I gave up. And I'm just completely uninterested in any of the new features. They're all the very bad versions of the features. Like, no, it's not possible for C++ to add good features anymore because everything has to be backward compatible with all of the old stuff. And all of the old stuff is a bunch of poop at this point. It has been for a long time. And so everything new that they try to add is weighed down by the fact that there's this entire language it has to operate with. And I think you see that in practice. When modules came out, I was on record saying on stream, I don't know if there's a clip anywhere, but I was saying, I bet modules are going to be really slow and not really provide any compilation speed benefit. And to this day, that's what I've sort of heard is the status of them. Okay. Matched multiple target types. Here's the type restriction. 0, 3, 4, and 5. 0, 3, 4, 5. Why 4? Why 4? Target type U16. Wait, that's not correct. That's not correct. Are we not? What? What if we put U8 first? 0, 1. It says target type U16. So maybe it's just not printing the right thing. Target type, match arrow target type. Why don't we use the input here? Oh, no, because that's not... All right. Target type. We want CE. What is return type? I don't think we need that. Oh. I think we just say target type here. Word in Office builds significantly faster. How much is significantly? Okay, here we go. Cast count, perfect match. So that should not be. That should not be. I feel like we've got the arguments backwards. Check that types match. What the hell does source type mean? Source type, starring Donnie Brasco. Sometimes I just don't. Oh, type given. Okay. So this is totally backwards. This is CE source type. There we go. Okay. U16, U64, S64. Okay, that is the correct answer. Perfect match. Perfect match is not the right answer, though. That's because we're never setting the cast count, are we? Well, it's not the right answer. Okay, this is not actually the right answer. This is all the things that we could cast to, but the whole point of this is the U64 and the S64 should get thrown out because they're looser, and we should be left with the three U16s, and we will now delete one of these. So we're left with two U16s. So we're just not storing the cast count, right? So in matching, okay, here's what we're going to do. We're going to say we need to know if matching, if old expr not equal to input expr given, a cast was inserted, or or a numeric literal could have been generated, and that's the pain. That's the pain. Um, cast count from number flags. I want some function that just does it. All right, let's just do it the gross way. We can look it up in the morning. Number of flags from numeric flags, literal value flags. Okay. Okay, wait. Number cast count. Is that just a... Can we just use that? Number cast count. Yes. Okay. If nf overload info.cast count equals literal number cast count handled equals true, All right. If E type you asked cast, right? Overload info dot cast count equals literal, or no, asked cast count, I guess. Handled equals true. If not handled, I would have sworn we had something to do this in matching, but I don't see it right now. It's not 2035 yet. No, thank you. Okay, if it's not handled, ice cite unhandled expression in the hell is this function? Passes implementation test. All right. We'll probably hit that, honestly. Cast count is not a member. Cast flags, cast by what? Maybe it's in typer. Cast count. Cast count add. Cast count from number flags. Oh, I guess we just say bit. It's in general .h now. So we have who sets bit distance? That's okay. It's there. Cast count from number flags, right? Um, count from number flags. So that's being called here. Implicit cast unhardened literal. So that's what fills this out that we're looking at. So we're using that already. We need it in a different case. So this is the overload checking. Okay. We can factor this out. This is what we want to use. Okay. 5603. Okay. Add cast count from cast count comma cast. All right. Okay. So we're going to have void add cast count from cast, cast count, cast, return. Okay. Let's say due to, because from makes it sound like it's stored on the cast or something. Due to cast. Okay. Now, here, we're going to do that because it's C++. You have to do everything twice. Add cast count due to cast. Overload info.cast count. And then cast. Boom. All right. Hey, look. It filtered out everybody but the U16s. All right, so now the test is to take out the U16s completely because we've got the U8. The U8 is a perfect match. The point of this is that we want it to try to up match, which it should be able to. Target type U8. Oh, we've got two U8s. That's not what we wanted. All right. There we go. Okay. I kind of don't know. I guess U16 casts to U64 better. Okay. And we're not returning the right value. We should never get U16 out of this, but it's working mostly. Mostly. How? Target type is constant expression. Maybe all right, this might be a thing for tomorrow when we're fresh because it looks like we're returning the right thing. We could double check this. So we should never return U16. We should be returning probably U64, and we'll check this. So we're going to go here. Get rid of this. Is an old breakpoint we don't want. Okay, matches. 2, that's going to be S64 and U64. Right, so we have interp type def S64, interp type def U64. So you see these, I mean, I did them in the opposite order, but these match these. So cast count for S64, bit distance $48. That's correct. But I don't see a signedness difference or anything. Cast count. Bit distance 0, that's not right. That is not right. In Interesting. That might be related. Bit distance 0 is what we would get if it was the wrong thing. All right. So S64, U64 is number 1. This is number 0. This is number 1. Okay. Matching is going to be true. Okay. CE is interp type def U64. You see that. Input expert given type should be a cast now. Yes. Now if I say inferred type, that is equal to CE because we casted it. And that is equal to type def U64. So this should be fine. It is a cast. Add cast count due to cast. Wait. How would we be getting the bit distance here? We're not... Oh, from here. Okay. Cast count from number flags. That should give us a non-zero bit distance. Wait. I think I had it backwards. I think I thought S64. This is going to give us our 48-bit distance, right? Wait, why do we have an overload info? Oh, it's this. I called it the wrong thing still. It was originally an overload info. All right, so this is correct. It's the S64 that was not right. Okay. CE is now the 3.0, which is S64. Matching is true, which it should be. Inferred type S64. Did we yield? No. If it's literal, if it's cast, okay. 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 F new, F old. Whoa! Oh, shit. Okay, guys. This is, again, one of the problems. Okay, I see what's happening. So we're checking to see, like, did we did somebody insert a cast on this thing? Okay, first of all, we're leaving the cast on there. So if somebody inserted a cast, then we're leaving it there. So that's a problem. So here we're going to go, no matter what happens, Okay, so now it matches U64 and S64. Bit distance 48 for each of them. That's great. So now it's still going to be wrong, though, if we take out S64. So now it'll match U64, but it's still going to say U16 probably. So this is what we have to debug. And I think what's happening is just we don't leave the cast on there ever. And so, like, we return a type from this function, but I haven't looked at in these sessions where that goes when we return that type. And it looks like it's not actually being used to generate an actual cast, etc. So if we're going to put the cast back on, which also wouldn't matter, because it didn't matter, but we're going to want that cast back. So we need to put it on this thing. All right. Wait. Yeah. Overload info, index, target type. Casted expression is new expr. Which could be equal to old expr. All right, this won't fix anything because we're not using that. But we're just getting it in place. And then I think it's bedtime. And we will have to debug that tomorrow. It seems like a small thing, actually. But then we've got more test cases to do. This is a simple integer test case. We need to test, structs, casting to structs, and all sorts of things like that. Europe time zone stream. No, it ain't, because I'm going to bed. 20% speed improvement over PCH. Dude, that is such a... Given how incredible amount of waste C++ does when compiling, 20% is embarrassingly little. I mean, I know it matters when it takes 2 days to compile your program, but the problem is that it takes 2 days to compile your program. The problem is not that you could save 20% of 2 days. Right? Like, it's just horrendous. All right, everybody. Thanks for hanging out again. We're almost done with this feature. Maybe we'll get it done tomorrow, although tomorrow's kind of a busy day for me. So maybe not. Maybe not. We'll see. Oh, dude, I just realized I need to be able to compile the game. I hope I didn't break it. I probably didn't. I can just keep all this new code, and if I want it to be compatible with the old code, I'll just reject the match if the expressions are not equal. Dude, this guy has crabs. Retro roguelike RPG development with cards. It's got cards. Dude, retro roguelikes did not have cards. Okay?
That means the card's still there, but it needs to be used.
Why is every game a card game?
2-1.
What the actual F is going on? Let's do weird greasy mustache guy. All right. Thanks, everyone. See you later.